Hello students, welcome to statistics classes. In this video we are going to work out a problem on fitting a Poisson distribution, that is obtaining theoretical frequencies, which is also called as expected frequencies for a Poisson distribution. The problem will be like the observed frequency distribution table will be provided to us, with the help of which we will be calculating the expected frequencies. ನೋಡಿ, ಕ್ವಶನಲ್ಲಿ ನಮಗೆ ಅಬ್ಸರ್ವ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸೀಸ್ ಆಫ್ ಎ ಪಾಯ್ಸನ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಕೊಟ್ಟಿರ್ತಾರೆ. ಅದರ ಬೇಸಿಸ್ ಮೇಲೆ ನಾವು ಎಕ್ಸ್ಪೆಕ್ಟೆಡ್ ಫ್ರೀಕ್ವೆನ್ಸೀಸ್ ಅಥವಾ ಥಿಯರಿಟಿಕಲ್ ಫ್ರೀಕ್ವೆನ್ಸೀಸನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. See, the question looks like something in the form of a frequency distribution table, like the question 1 you are looking at the screen. The following mistakes per page were observed in a book. So, the data provided to us in this table is relating to the number of mistakes per page observed in a book. So, as they are using the word observed, these are observed frequencies, actual frequencies. So the table has two rows, which is number of mistakes per page and the numbers they have given from 0 to 4 and number of pages. So from the table we can understand that in 211 pages there is not even a single mistake, that means 0 mistakes. So one mistake irontaha pages 90 ಇದೆ, 2 mistakes pages 19 and 3 mistakes ಇರುವಂಥದ್ದು 5 ಪೇಜು, 4 mistakes ಯಾವ ಪೇಜಲ್ಲೂ ಇಲ್ಲ. So with the help of this table we are going to fit a Poisson distribution and obtain expected frequencies. Let us see how to do that. See, before going to fit a Poisson distribution, we need the parameter of the Poisson distribution. Parameter of the Poisson distribution is lambda. But nowhere in the question the lambda has been mentioned. So we should first of all find or calculate the value of lambda. To calculate the value of lambda, we should just calculate the mean of the given distribution. The given distribution table is in the form of a discrete frequency distribution. So for discrete frequency distribution, we can calculate the value of mean with the help of a formula, that is summation of fx by n. So let's rework the table with 3 columns. The number of mistakes in each page is taken as x and number of pages is taken as f, and add one more column, that is fx, f into x. So multiply the x into f. In the first case it should be 0 into 211, that can be 0. 1 into 90 is 90, 2 into 19 38, 3 into 5 15 and 4 into 0. So add the total of fx. Now apply the formula, mean is equals to summation fx by n. So the fx is 143 divided by n total, that is frequency total is 325. Therefore you will get the value of mean is equals to 0.44. In a Poisson distribution table, the value of mean itself is the value of lambda. Lambda is equals to mean of the distribution. Therefore you can take lambda is equals to mean is equals to 0.44. So ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿರುವಂತಹ 0.44 ಇದೆಯಲ್ಲ ಮೀನು, ಅದೇ ನಮಗೆ ಲ್ಯಾಂಬ್ಡಾ ಆಗುತ್ತೆ ಇದರಲ್ಲಿ. So once you know the value of the lambda, you can proceed with calculation of probabilities. Starting from P0, P1, P2, you can calculate all the values. Now let's use the probability mass function PMF formula of Poisson distribution, that is P of x equals to e to the power of minus lambda into lambda to the power of x divided by x factorial. So once you proceed with calculation of P0, you can just take e to the power of minus 0.44 into 0.44 to the power of x, that is 0, divided by 0 factorial, so that you will get 0.44 only. So to find the value of e to the power of minus 0.44, you should visit the Poisson and exponents table. So 0.44 means you should take this value, that is 0.4 under 4. 0.4 here and the next 4 here. So 0.44 ಅನ್ನೋ ವ್ಯಾಲ್ಯೂ ಯಾವ ಥರ ನೋಡ್ತೀವಿ ಟೇಬಲಲ್ಲಿ ನೋಡ್ಕೊಳ್ಳಿ. 0.4 ರೋನಲ್ಲಿ ಫೋರ್ತ್ ಕಾಲಮ್ ಕೆಳಗಡೆ ಇರುವಂತಹ ನಂಬರ್, ದಟ್ ಈಸ್ 0.6440, that should be the component value of e to the power of minus 44 ಅಂದರೆ 0.644. 0.644. So 0.644 will be the value of e to the power of minus 0.44. That means probability value of 0. To get first theoretical frequency term, you can multiply the P0 with n. n multiplied with P0. ನಾವು ಬೈನಾಮಿಯಲ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನಲ್ಲಿ ಯಾವ ಥರ ಮಾಡ್ತೀವೋ P0 into n is equals to T0 ಅಂತ ಸೇಮ್ ಮೆಥಡ್ ಈಸ್ ಅಪ್ಲೈಡ್ ಹಿಯರ್. Therefore n into P0 equals to 325 into 0.644. 325 into 0.644. That means you will get 209.3, that can be 209. So you got the first term, the first theoretical frequency term, that is T0. And from here on you should calculate T1, T2, T3 and T4. Now once you calculate the first theoretical frequency term, you can use the recurring formula. You can use the recurrence relation formula. The recurrence relation formula in the case of a Poisson distribution is Tx is equals to lambda by x into Tx minus 1. The recurrence relation formula for a Poisson distribution table is Tx is equals to lambda by x into Tx minus 1. That is, let us say in the case of T1, lambda is 0.44 divided by, as you are calculating the value of T1, x will be 1, therefore by 1 into Tx minus 1. When you are calculating T1, Tx minus 1 is T minus T1 minus 1. So 1 minus 1 will be 0, therefore T0. T0 value already we have taken 209.3. We just calculated here 209.3. So you can take that 209.3 here. So 0.44 by 1 is 0.44 into 209.3. That comes to 92.092 or 92. In the same manner, let's calculate the value of T2. Lambda by 2, that is 0.44 by 2 into T1, that is 92.092. So 0.44 divided by 2, if you calculate, you will get 0.22 into T1 value is 92.092. So just multiply both of that, you will get 20.26, that is approximately 20. Proceed to the T3, that is lambda by 3, 0.44 by 3 into T2, so that you will get T2 value 20.26 iratala, adana just multiply 0.44 by 3 into 20.26. If you calculate, you will get 2.97, or approximately you can take it as 3. And the last one is T4. Again lambda by 4. Lambda is 0.44. Therefore lambda by 4 into 2.97. That is lambda by 4. If you divide, you will get 0.11. That is 0.44 by 4. 0.11 into 2.97. You will be getting 0.3267. You can take, it's nearing to 1. So once you got all the values of theoretical frequencies, put that in the form of a table. Number of mistakes per page, that is x. Observed frequencies, which is given in our question, and expected frequencies, those which we have calculated now. So you can put them in the form of a table. The total should be same, observed and expected frequencies. So the round of expected frequencies is presented in the form of a table. This will be the Poisson distribution theoretical frequencies. You should learn the recurrence relation formula for Poisson distribution. It's pretty simple. Tx equals to lambda by x into Tx minus 1. Tx minus 1 is very simple. When you are calculating T1, that is T0. When you are calculating T2, it will be T1. So the previous theoretical frequency answer, that's it. So practice this on paper, and if you have any doubts, you can just reach out to me.